Okay, let me show you how to do some torque problems. So from the reading and the videos previously, we know hopefully that torque, which is this curly T, can't quite see it, let me move the camera. It's a Greek letter tau. It's equivalent, or it's equal to, the force perpendicular times the lever arm, the distance to the axis of rotation. So in this problem here, here's the axis of rotation, the middle of the bolt that you're turning on this wrench. This is L. The distance from that axis to where that force is applied, that is L. That is lever arm. Now, the portion of the force that causes the wrench to rotate is only the perpendicular one. There's two components here. There is the component that is this way, F parallel, but that doesn't do anything. That pulls the wrench off the bolt. It doesn't twist it. F perpendicular causes all the twisting. Now this is the whole F this way. These are the components. This hand is actually pulling off at an angle, but this portion of the force that's parallel to the wrench isn't doing anything. It's pulling the wrench off. It's only the perpendicular one that's causing any kind of turning in this case. So we take the product of the force perpendicular times L. Now I'm saying here this force is 8 newtons. This perpendicular portion is smaller than that. So in this case I'm going to say it's 6. The way we would figure that out, we could use trigonometry, but you won't have to do that in this course. You just need to know that it's only the perpendicular component that causes it, and we'll give you that perpendicular component. So the perpendicular component is 6. The lever arm is 0.2, so the torque in this case is 6 times 0.2, which is 1.2 Newton meters. Force times distance. Similar to the unit for work that we had earlier, but with work, the Newton and the meters, the distance moved, were parallel. Here they're perpendicular. And this is not the distance moved, it is the distance to the axis of rotation. So you merely multiply force times distance. This one's a little easier. So here we got the same R, same distance from the axis of rotation, but now the entire force is perpendicular. So that is the force perpendicular. So the torque here is 8 times 0.2, which is 1.6 Newton meters. Now this one, let's slide along. Whoop, whoop. So same force, but now we put an extender on this. So we're further out. So we got even more torque. So the torque, again, is the force that's perpendicular times the distance to the axis of rotation. Here we got 8 newtons. But now it's 0.5 meters away. So that's 4.0 Newton meters. That's much larger torque. So a longer wrench helps you break bolts that are stuck. They call it a breaker bar sometimes, when a bar you put over top of a wrench to apply more torque. Make the twisting easier. All right, so there's some example torque problems. Hope that was helpful.